We just haven't revealed such syntax. So let's actually see this work. So I've gone ahead here and launched the CS50 appliance. I've opened a file called swap.c. I'm going to go ahead and zoom in on what is now the correct solution to this problem. So I've got some boilerplate stuff up top, includes standard io.h. I then have the swap prototype. And now this is a copy-paste of what we just saw in the green slide, but it ends with the semicolon. And that's just, again, the clue saying, hey, swap is going to exist. It's a message to GCC, the compiler. So now main. We've seen this half a dozen times now where I assign x a value, y a value, and then I claim I'm swapping them, but then they never actually swap. But there's one more key syntactic difference this week that we didn't look at last week. You do have to change the syntax that you use when you actually want to pass in a variable or two variables by their address. You can't just say x. You can't just say y. You have to say, give me the address of x and the address of y. And you can perhaps infer what the relatively simple syntax for that is a single ampersand. By putting an ampersand before a variable's name, you're telling the compiler, go find the address of x and pass that in. Do not pass x in itself. Now, just a word on types. So x and y are indeed integers. So what is the data type of ampersand x, would you say? How would you answer that question? What's the type of ampersand x? So it's the address of operator. So it is passing in an address. Well, what does that map to? Well, that just maps to, no need to project here, that just maps to int star. So anytime you have a pointer, pointers are meant to point to specific things. So if you want a pointer to an int, you would typically, if you're going to write it, say int star. If you want a pointer to a char, you say char star. If you want a pointer to a double, you say double star. So in this case, ampersand x, I don't have to mention x at all. I don't mention star because x already exists. At this point in the story, in this highlighted line, this call to swap, all I want to do is tell GCC, x, whatever data type it is, happens to be an int, get its address, and pass that in. So now what does swap look like? It looks exactly as was promised. In the swap function, we say int star a, int star b. So now a and b are effectively local variables. They're parameters, but they're local to swap. They only exist at this point in the story. What gets stored, to be clear, in a? So the address of x. And what gets stored in b? The address of y. So now we can't implement swap in precisely the same way we used to, because notice what would immediately be bad about this. If I go in and manually delete all of these stars for just a moment, if I leave it alone as this, what am I actually doing with the swap function now? What am I swapping? So I'm just swapping their addresses, but that's not what I want. I want to go to whatever a is pointing at, which is x. I want to go to whatever b is pointing at, and that's y. I want to change those values, and then that's it. It would be completely meaningless just to change the addresses, because at the end of the day, if you put something at address 1, 2, 3, 4, 5, that's where it is. If you put something else, y, at 4, 5, 6, 7, that's where it is. If you want to change those values, you have to go to those locations. You can't just change the locations themselves, the addresses themselves. So what does this mean then if we walk through these three final lines? So the left-hand side here declares an integer called temp. And that's how many bits? Just a quick sanity check. So it's 32 bits in the appliance. Could be 64 on more modern hardware, but in the appliance and in a lot of computers, 32 bits. Now, star a means what in English? OK, the location of a, but not quite the location of a. Star a is so the star in this case is the dereference operator. And so star a means go to that address and find what's there. So a quick sanity check. If I hand you the address, and it's called a, and I say, go to this address, what are you going to find when you show up at that address? X, the number 1. So what is stored in temp right now is simply the number 1. OK, so now in the second line here, star a means go to a. So what's currently at a? So the number 1, AKA x. So what am I putting there based on the assignment operator, based on that equal sign? Well, I'm saying go to b. So I'm going to b, and what do I find there? So I find 2, AKA y. And so now it's saying take that value, 2, put it at star a, which now has the effect of putting the number 2 where the number 1 once was. So at this point in the story, there's x and there's y, and there's a and b respectively pointing at them. But what two values at this point in the story are in locations x and y? They're both 2. They're both the number 2 at this point. So all we have to do now is fix the mess we just made. We made 2 copies of 2. We need to now put the number 1 back in the location y. So temp, you already said earlier, is the number 1. And there's nothing new there. Temp is an int. It's as simple as that. It's just this number we put there, which was 1. Star b means go to wherever b is pointing. And that is the location we think of as, so that's y, right? Star b is y. So what do I put at y's location? The number 1. So that's a bit of a long tail to tell just verbally, but recall how we can actually see this relatively simply step by step. Let me go into my source directory. Let me go ahead and make swap, which is the name of this file. Let me go ahead and run it just as a sanity check. And it does seem to be finally, all these weeks later, working properly. But that all happens too fast and underneath the hood. So let me go ahead instead and run gdb of swap, enter. I'm going to go ahead and run it here. OK, that wasn't all that useful, but it did run into the confines of GDB. How do I actually pause execution and step through this? So I want to actually do break it. Let's just break at the beginning. Break main, enter. It's now telling me there's a breakpoint at some crazy address, and that's where the program physically is in memory, in the file swap.c line 22. And if I actually scrolled up, the very start of main would indeed be at line 22. So now I type run to run the program, but I'm instantly going to hit that breakpoint. So now we can just step through this one step at a time. So int x gets 0. So let me do a print x, and that's already wrong. Why? Yeah. It's the address. So it's actually not the address here. This is literally the value that's at x.
It's using what was stored there before. You have to hit continue.
Exactly. So this is an example of one of these garbage values, right? Just because we see that we're at line 22, remember with GDB, it shows you the line before it actually executes it for you. So at this point in the story, I've not yet executed line 22, so x has not been set to 1. So what in the world is x? Well, we never know. It's probably some garbage value that's there from some previous function call or some previous use of that location. So if we ran this all day long on different computers, we might very well get different numbers again and again. But the point is that it's just wrong. It's not a useful number. So now let's type next. And this will actually move me to the next line. It's not yet executed line 23, but if I now do print x, I should see 1. And again, don't be confused by the $2. This is just a fancier feature so that if you want to refer back to some value you printed earlier, you can still access it by way of this $sign notation. But you'll for now, you'll rarely need to use that. All right, so let's just go ahead and do next. Let's do next. Notice now it all of a sudden said x is 1, so it's actually printing the printfs. Let's do next. All right, it's about to say swapping, so let's do next one more time. And now before we dive into the swap function, let's do a little sanity check. Let me clear the screen and print x. OK, let me print y. So the state of the world is as we expect. So if I do type next, what's about to happen? So they're going to get swapped, but it's going to kind of happen all of a sudden. I'd actually like to see what the swap function is going to do. How do I actually go inside of the swap function? So you do step. So step steps you into what's about to happen, as opposed to next, which steps over. In both cases, though, they'll make the code execute, but all at once or one step at a time. So now notice we're in swap. And not to make things look a little too crazy, but I'm going to do a new command, backtrace, just in case you start to get lost in where you are. If you type backtrace, you'll see a quick, if arcane summary of those frames that we keep drawing on the board as rectangles. So unfortunately, fortunately, it draws them in the right order. Notice at the bottom of the stack is main. It's indicated with number 1 here. And then on top of that is number 0. It's kind of unfortunate that they reverse the numbering. But we can now see those stack frames. And so what do we have here? We're inside of the swap function. So what's about to happen is line 42 is about to get executed. So if I print out temp, what's actually going to get displayed on the screen? If I print temp. Yeah, so it's going to be some garbage value, right? Because this line has not executed. So again, there's no right answer. Happens to be 0, but we're just lucky. So if I actually now print out, let's say, star A, what am I going to see? So I'm star A. So star means go there. It's the dereference operator. And if I go to A, what am I going to see? So I should see 1. So let's do a quick check. Print star A. I do see the number 1. If I instead just print A, what should I instead see? So the address. And again, mostly meaningless, but it is in fact the address in RAM of where A, or rather of what is inside of A. So when we say the address of X is in A, where is X? Well, it happens to be at that address there. OK, so let's just move on with the functionality. So if I type next, that line of code up here is going to execute. Int temp gets star A. So when I type next and now print temp, I should see the number 1. And if I print star A, I should also see the number 1, because we've moved star A into temp. The next line of code that's about to get executed is this. So as soon as I type next and then print out star A, it should be this time. So not 1 now, because we just executed this line that I've highlighted. So star A equals whatever is at star B. What was at star B? 2. So star A is now 2 as well. So we seem to have now put into star A the number 2, and in star B is the number 2. So we have that just one last step. So now the last step, recall, is go ahead and replace what's at location B with whatever's in temp. Well, what's in temp? 1. So what's at star B? We already know it's 2. So in a moment, when I type next, hopefully this will have clobbered the value at star B. And in fact, it's the number 1. And at star A is 2. So if I now I'm getting bored of this debugging, I'm just going to type continue. And that's going to run to the end of the program. Voila, it's claimed swapped. X is 2, Y is 1. So there should be 2 takeaways here. So one, exactly what the difference is between just saying A, just saying B, and saying star A and star B. And what the difference is between saying X and Y versus saying ampersand X and ampersand Y. And then lastly, more in practical terms, again, just going through this process of using GDB, even though it might feel a little clunky or a bit tricky to wrap your mind around at first, is incredibly useful as you start to try to find bugs in your own code. Does the pointer have a scope? Yes.